Yes, so welcome to lecture 20. So, before the earlier lectures, we have discussed about the working principles of the state variables. State variables are the core theme of this crop production models. So, state variable that indicate the state of the systems at a particular time frame, at particular state of time, how the condition of the systems that may be biomass, that may be soil water, that may be soil nutrient, soil carbon. So, those are the state variables. So, that indicate the state of system of particular time. So, here we will discussing about the crop models for different production situation. If you remember at the beginning of the lecture, probably we have discussed about the different production situations like actual production, attainable productions and potential productions, and this lecture will be somehow going through review that lecture, initial lecture. At the same time, we will give some understanding how about the production situation that link to crop model. If you go for crop model, what are the assumptions, what are the criteria you are considering for these two different production situations. When you go for the simulation analysis, and if you know the production situation, we have the actual productions, attainable and potential productions, and models are built for all the production situations, and this the users who are using the model. So, he has to choose what type of model they are using and how they are going for the as per the user interest, what are the input optimization, what are the parameters they want to simulate, what are the input factor they want to simulate there, and what is the output they are interested. So, you have the three production situations we have discussed earlier. So, in this exercise, in this lecture, we will discuss how the modeling scenarios are used to compute of these three production situations. So, like earlier I have discussed about the actual yield, attainable yield and potential yield. So, crop estimation model represent the interaction, which is a very basic one, soil, climate, crop genotype and management. So, that model helps estimate the yield potential definitely. So, three levels of productions: potential productions, attainable productions and actual productions. So, if you remember the earlier class, the actual yield, attainable yield and potential yield. So, potential yield is the maximum yield. So, particularly this we do get in case of the controlled environmental experiment. In case of the greenhouse, so that is a controlled environmental agriculture, where you maintain everything optimum, means your weather parameters are optimum. At the same time, the crop gets the sufficient amount of water and nutrient, means the crop does not suffer from nutrients or water stress, and also the crop is well protected from pest and diseases, that is say the potential yield. If you come to attainable yield, means the here this is represent the open field condition, not the as a greenhouse or the controlled environmental experiments. So, this is open field conditions, where we do take care of the water and nutrient management. We do not take care with, because it is very limited facility to take care of the weather parameters. The open field, so you have to grow the crops, you have to manage the crops in the open field conditions. So, where we take care of the pest and diseases, and in addition to that we take care of the water and nutrients to make sure that the crop does not suffer from any water and nutrient stress. And the lowest yield is the actual yield. This is the yield where we get from the farmer's field. So, this yield, the farmer's field yield, what farmers used to take care of as a weeds and take care of the pest and diseases, but farmers do fail to take care of the water and nutrients, means they apply nutrients, but the nutrients are not very specific to the need of the crop and the soil. They do go for the conventional method of the fertilizer applications without understanding the soil fertility status, or without knowing about the crop demand for the nutrients. They go for the blanket application or the normal applications as they used to do earlier. So, that is what also water. Water is very precious, the farmers do apply from their own understanding whether the crop needs water and the amount of water also, that what stage to be irrigated. So, from there the practical exposure only they do supply water, and they fail to also to know the depth of water irrigation to be given. It may be very high, it may be very low in case of irrigation resource is available. So, here the farmers, because of the lack of scientific technology or scientific inputs for the water and nutrient management, the yield remains low, that is say the farmers field yield, where the farmers can take only the control the weeds. No, weed control is no, they can use the mechanical method or physical methods to control the weeds. And the pest and diseases issue, the farmers used to take care of the pest and diseases by taking use of the chemical measures or any other the integrated measures that take care of the pest and diseases. So, that yield is the farmers field yield, actual yield. So, from that if you proceed, if you take care of the from this you could take care of the water and nutrients, apply proper water and nutrient, we get this attainable yield. That is what yield we get in experimental stations, research stations we get this attainable yield. And after this the attainable yield, if you provide the optimum weather parameters, then you get the potential yield. So, this is what we discussed the earlier classes. Now, we will go for the how the modeling scenario is employed to simulate the crop for these three production situations: actual, attainable and potential yield. So, this is the conceptual framework for the production level, three production levels, one is the actual yield and attainable yield and the potential yield. So, actual yield, the farmers do take care of the pest and diseases, particularly these are the yield protecting measures, control of the weeds, pest and diseases, these are the yield protecting measures. If you control, you get the actual yield, that the farmers field yield. Then after this actual yield, then yield reducing factors, these are the that is say limiting factors, the water and nutrients. So, water and nutrients limit your yield from the attainable yield. So, if you supply this the water and nutrients, proper water and proper nutrients, I do not say excessive water or the deficit water, the precise water as per the need of the crop. Excessive water does not enhance the yield, rather decreases the yield. Similarly, deficit water also puts a stress, that also reduces the yield. For the water management, you have to be very precise, the exactly the quantity and the timing, the quantity of water and the timing of water application, that should be very important. Same for the nutrient management as well. We have to supply the nutrients at the right stage of the crop growth and the right amount. For excessive applications, that causes loss and also that brings a reduction in crop yield. And for the non timing, this is if the nutrient is not applied at the right time, right stage, also that is not usable for the crop, that causes, that does not lead to enhancement of the production. So, water and nutrients are two inputs, this has to be applied at the right time of the stage of the crop growth, that is a proper stage of the crop growth and the right quantity, then you can achieve the attainable yield. So, the difference between the attainable yield and the actual yield, this is the yield gap. Say the yield gap, no, we are all the scientists or engineer trying how to bridge this yield gap, how we can reach the attainable yield. This yield gap that varies from 50 to more than 50% to 10 to 20% all over the Indian states. If you see some states like either the Punjab, Haryana or the south, you can say Karnataka, some state Tamil Nadu, some state they have the yield gap around less than 30%, but the states like eastern India like Bihar, Chhattisgarh, Odisha, some West Bengal also, the yield gap is in case of rice crop I can particularly say is more than 50%. That means, so there is a huge scope to bridge the yield gap, to reduce the yield gap by using the proper technology of this water and nutrient management. You can provide the optimum water and optimum nutrient, we can minimize the yield gap, we can reach this attainable yield. And after you reach attainable yield, then these are the weather parameters are the yield defining factors we can say. So, these are the either the radiation, temperature, then the crop physical characteristic, once the temperature, water, sorry temperature. So, these are the other parameters. So, that you can give the potential yield as defined by the breeders. In case of the this is only limited to few crops, cash crops we can say high value crops which can be grown in the controlled conditions and the smaller area I can say, but for the rest of the main crops we can say rice, wheat, the pulses or the oil seeds is very difficult to grow in a controlled environment experiment, because the requirement is a huge amount. So, we go for the open field, they have to grow this has to be grown open field. In that case, we have to go for the optimization of the water and nutrients to have the maximized yield. So, these are the basic concepts of the as a production situations. Now, let us go to how the models are used to meet this concept, and somebody the users like us use the models, what understanding you should have, what type of models are using as per our the objectives. So, if you see this one, this potential production simulations, I can say you see the maximum possibility as this maximum possibility. What are the key characteristics here? Key features are here, or key characteristics represent the upper biological limit of the yield, the maximum yield. You do not get the yield beyond this one. So, potential yield possible for this particular variety, for a particular location we can say. The growth is governed by the genetic potential and the particularly other variables. We exploit the maximum potential of the crop through optimizing everything, all the inputs. We can optimizing the having the proper pest control measures. As a plant protection measure, we protect the crop from pest and diseases. Then we provide the sufficient water, sufficient means optimum water and nutrients, and then the crop is grown in a optimum weather parameters, that you get the potential yield. So, that is a major processes here where the model does if you are using a model for potential production simulations particularly. So, what are the major processes here? The photosynthesis, respiration, dry matter accumulation, growth and development, and these are the regulated by these weather parameters only. So, that is a model assumption. The model, if you are a model for the potential production simulation, the model assume the crop is well protected from pest and diseases. That means, this module for the actual yield simulation is switched off in that model. So, we do not need any data for this pest and disease. So, this module is switched off, and the second one, second assumption, the crop does not suffer from water and nutrient stress. So, the water and nutrient stress, this module also switched off in this model. That means, so the crop only respond to the weather parameters. To simulate the crop yield, only the inputs are the weather parameters. The crop does respond to weather parameters. All other options, all other modules are switched off. This model we cannot simulate the actual production or attainable production. These two cannot be simulated, only you can simulate the potential production, and these are regulated by the weather parameters. And for these potential production simulations, the model assumption is there is no pest and disease influence attack, or the crop has no suffering from the water and nutrient stress. So, that is what the models are available for potential production simulations. The other one, the attainable production. In case of attainable productions, so that yield is not regulated or the influenced by the water and nutrient managements. So, here the key characteristic, water and nitrogen are the primary limiting factors. So, we need to take care of the water and nutrients, simulate the realistic field conditions with the resource management, particularly water and nutrients. Pest and disease effects are not considered in these models, reflects the economic yield potential that can be done. So, please keep in mind, so for models for the attainable production, what the model assumption, the crop is well protected from pest and diseases. That means, if the model is built for attainable production, there you cannot simulate actual productions. That means, this module is switched off. The pest and disease module, that is switched off in this model. The crop model is built for the attainable productions, where the actual production simulation or the pest and disease effect on the crop is switched off. So, what you can simulate? You can simulate the effect of water and nutrients to have the attainable productions, and also you can simulate the effect of weather parameters. That means, the model is built for attainable production situation, attainable production simulations. You can simulate the effect of water and nutrients, and also we can simulate the effect of weather parameters to reach the maximum yield. So, that is what the attainable production simulation. So, you can find the models available for potential production simulations. Models are also available for attainable production simulations, where you can simulate the effect of water, effect of nutrients, and effect of weather parameters. Here only you cannot simulate the effect of the pest and diseases, cannot be simulated if the model is built for the attainable production simulations. So, this is what is characteristic of this model. So, if you go to next one, that is a actual production simulation. This is actual production simulations, where the yield is realized in the farmer's field. This is a farmer's field, where the multiple constraints they operate. So, here this is the real condition. You can see, if you are going for the simulation. So, farmer's field, you can apply the model to know the model can simulate all. That means, see the assumption, you can see there is no assumption. That means, you can simulate the effect of all factors. You can simulate the actual production, you can simulate the attainable productions, you can simulate the potential productions. So, there is no assumption in model. So, here you can simulate the effect of pest and diseases. So, when you go for the yield simulations for this the models for the actual production level, you can simulate the effect of pest and diseases, then you can simulate the effect of water and nutrients, and also you can simulate the effect of weather parameters. That means, the model built for attainable production actual production simulation, you can simulate all factors, all input managements that can be simulated here. That means, the pest and diseases and the water and nutrients and the weather. So, let me see the key characteristic of this model affected by the biotic factors, that is weeds, pest and diseases, and the abiotic water and nutrients, which could be can be simulated through this model. Influenced by management practices, yes. So, like planting date or the reflect on the real world. So, what I can say here, the model is built for the actual yield simulations. There also you can simulate the effect of planting dates, irrigation scheduling, land preparation, everything in the model built for actual productions. You can simulate all input factors except pest and diseases. Model for attainable productions that can simulate effect of all factors except pest and diseases, and model for actual production, see addition of pest and diseases in attainable productions. So, you can whatever the simulation you can do, in addition to that you can simulate the effect of pest and diseases in case the model is built for the actual production simulations. So, that is what we can see, if the model is built for the actual production simulation, where all factors can be simulated, pest and disease and the water and nutrients, because water and nutrients, in addition to that we see, I have discussed earlier several management factors starting from land preparations to harvest, tillage operations, everything can be simulated in attainable productions. And actual productions, whatever is simulated in attainable productions, all plus pest and diseases. In attainable production models, only you cannot simulate the effect of pest and diseases. So, from this I can say, you can understand which model is very important, either the model for the potential productions, which simulate only effect of weather parameters, or model for the attainable productions, which simulate the effect of all parameters except pest and diseases, or the model for the actual productions is simulate all with pest and diseases. So, in this case, if you see the model, now that is earlier only we are getting the models at the attainable production levels. So, now models are available actual production, even the DSAT model you will be using DSAT software, for this modeling exercise, that also simulate the effect of the pest and diseases. So, many models are available for the starting from the actual production level. This is required that gives understanding the farmers the what type of the disease control measure you can do, how much pesticide you can apply, the dose of pesticides and the time of pesticide application. So, that you can minimize the damage to the pest and diseases. So, that you can enhance your production. So, on the top of that once you have the actual production, then you go for the for the water and nutrient management, you can go the proper water, proper nutrient, then for this as a weather parameters. So, if now we can think the type of the data set required for the model development, the models are potential productions, model attainables or the actual production simulations, the which model require the maximum input data. Definitely, if you see the model built at actual production simulation, it require extensive and intensive data sets, all data sets to have simulation, but only in case of potential production simulations, because all the modules are optimum, all the models are switched off, that requires only other parameters, but all other models they needs the details of the data sets for as model development, and for the real world use we need the models at the actual production simulation. So, this is where the different production situations where the models are built. So, relationship among the production level, we can say this the yield gap analysis. We are discussing yield gap, that is a difference between the attainable and the actual yield. So, this is the attainable yield and the actual yield, this is the yield gap. So, we have to all modeling application identify the yield constraints, then quantify impact of the limiting factors, then support site specific management recommendation. So, the main aim of the this crop modeling and simulation exercise, or the subject is how to go for the input management, proper input management, and to minimize this yield gap. So, the yield gap, the many places it may be 30%, 40% or more than, some places it may be more than 50% also. So, using this modeling scenario by the help of the crop models, this can give recommendations particularly for the site specific recommendation you can say. So, what could be the management levels, so that you can reach the maximum production, so that you can bridge the yield gap. So, that is the purpose, so that the production level can be enhanced, and also the purpose the timely application of the inputs and the precise application of inputs that saves the input cost. At the same time, the environmental sustainability could be maintained. If you apply the suppose rice crop, the fertilizer, the same fertilizer is application timing is very important. So, if you apply at the time when there is a less use of crop, even though applying same quantity of fertilizer remains same, but there is a loss of fertilizer, crop is unable to take fertilizer because of the that does not match with the particular stage of the crop. So, that is very important, and also quantity definitely. So, quantity should not be a huge quantity application of the fertilizer that causes soil pollutions, air pollutions, water pollutions. So, that creates the unsustainable agricultural practice. So, now we are moving, because agriculture should be highly sustainable. It should have a less effect or no effect on the environment, you can say 0 effect on the environment. At the same time, it should be resource efficient. If you make a resource efficient, then the resource is utilized very efficiently, then the loss will be less, and they can minimize the pollution on the environment. So, these are the you can say these are the three production situations we are aiming for, and their models are available. So, when you go for the crop modeling exercise, so we will be working on this actual production model. So, where you can have the all the input parameters, you can put your data inputs, and you can see effect of the every input parameters on the crop performance. So, with this you can say the what is the from this summary and takeaways. So, crop models, they are characterized by the production situations, that is a potential is a ideal condition, there is no stress, and where only few crops are grown, controlled environmental experiment. Attainable yield, that is as the experimental yield, where the limited by the water and nutrients, mostly we are focusing to how to reach the attainable yield, and actual yield, that is real world constraints. Farmers face lot of constraints, as a pest problem, disease problem, water and nutrient problem, what the farmers used to get from his field with the limited knowledge and only used to take care of the pest and diseases, does not take care of the water and nutrients management very scientifically, or the optimum management of water and nutrient is very difficult to maintain the farmer's field. So, that yield you get the actual yield. If you can maintain, you can put your resources, optimize resources, particularly water and nutrients in farmer's field, then you will be able to reach the sustainable yield. So, this understanding, this level helps the quantifying the yield gaps, because we have to know what the yield gaps, then prioritize the interventions, particularly the water management or the nutrient management and the plant protection measures, so that you can reach the attainable yield, very close to attainable yield. So, that you can minimize the yield gap, then design the sustainable and climate resilient system. So, this helps in the particularly the proper input management, the resource efficient agriculture you can say. So, has a less emission of greenhouse gases and the optimized input management, that gives a maximize the production levels with reduce the cost of production also. So, that is what to make it the agriculture profitable. So, if you the production levels where farmers are applying huge amount of fertilizers maybe, and which is not required, that adds into input cost, also that creates pollutions and environmental pollutions, or they are not applying the fertilizer or water at the right stage of the crop. So, using this crop modeling exercise, so we can that can guide you particularly what stage and what amount we applied. At the same time, it gives a futuristic information. So, without going for the before going for experiment, we can understand what could be the expected yield, the forecasted yield for the coming seasons. So, accordingly you have to see the management scenarios, or when the crop is in the field itself, in season crop, there also if there is we can know how the crop is going on. So, how the yield is expected, we go for the in seasonal yield forecasting at the beginning of the sowing, at the mid season, that gives up the internal corrective measures. We can take some corrective measures to minimize the yield gap. So, these are the some of the things which can be taken care through modeling exercise, Hugo modeling exercise. So, that when you discuss about the DSAT software, the software modeling software, there will be also discussing this one. So, there is a in seasonal yield forecasting before the growing of the crops, that gives understanding about the proper how to devise your management practices, so that you can get maximum productions. When the crop in seasonal yield forecasting, that gives the corrective measures. So, if you know that we are the shortfall of productions, or we are on right stage, as you are moving the crop is a right stage, crop is performing well. If there is in the intermediate stage, there is a less performance, or the crop is not performing up to the mark to have a maximum productions, then we can through modeling exercise we can recommend the corrective measures, so that the yield reduction can be minimized. So, these are the production situations, and the modeling scenarios and modeling the characteristics or the assumptions in the models for these three production situations. So, next classes we will be discussing about the particularly the use of the how to go for the biomass and yield simulations using this crop model. So, 1 week the 4 lectures that will be focused on the biomass simulation and yield simulation for a particular crop models. Then we will move to the exercise or the discuss about the software, that is a decision support system for agrotechnical transfer. With this, I conclude this lecture. Thank you all.